Hello, today we are talking about two topics, symmetry and reflections. So with symmetry, we have two different kinds. The first kind is called line symmetry or reflectional symmetry. You can use whichever word you like. And that means the figure can be folded in half, and the two halves are exactly the same when you fold over. The key is it's got to be folded over. So when you picture a heart, when you fold the heart over that line, you should have two exact things on each side of the line. Not like my picture, but like a regular heart you would make. The other type of symmetry is called rotational symmetry. Rotational symmetry means you can rotate the figure and it looks the same as the original. So if I had a square, and this was a true square, and I wrote it, let's call this A, B, C, D, and I were to spin it around 90 degrees. If I spun it around, that means my A would end up over here, B would end up over here, C would be here, and D would be here, but otherwise the shape looks the same. So when I rotated it 90 degrees, the shape of the square looks exactly the same. Point symmetry is a figure when you turn it exactly 180 degrees and the figure looks the same as the original. So that would be if we were talking about a rectangle. So if I had a rectangle and I rotated that 180 degrees, again, I'm going to label it just so we can see what's happening. If I were to rotate that 180 degrees, then my A would end up over here. Wait, 180. My B would end up down here. My C would go here, and my D would be here. So although I would have rotated it 180 degrees, the shape of the square, the orientation of the square, rectangle, remains the same. So what we're going to do here is describe the type of symmetry for each letter below. Line symmetry or reflectional, point symmetry, which means we can rotate it 180 degrees and it's the same, both of those or none of those. So for E, I think that's pretty clear. There's line symmetry. I can draw right through that middle of the E. For the Q, when I spin it around, it doesn't look exactly the same. There's no line symmetry. So this one has neither. The P, again, there's no line symmetry where I can fold over, and if I spin it around, it doesn't change. So that's neither. The T has line symmetry. I draw it, sorry, it's not right through the middle, but I should draw that right through the middle. That's line symmetry. There's no point symmetry, because if I rotated that 180, the T would be upside down. So there's no point there. For the I could draw a line right here. When I fold it across, I get this, the same thing on both halves. And if I take an I and I rotate it 180 degrees, I get the same thing. So this one actually has both point, and this is point and line. My L, let's rotate that 180. If I rotate that around, I get that shape. So that's not exactly the same. There's no line symmetry, so that one's neither. My M, let's see. M, line symmetry looks like it goes right through the middle, so it's got line. If I rotate that 180 degrees, I get a W. So there's no point symmetry. So this one just has line symmetry. So what I'd like you to do right now, I'd like you to try the next row, CSOYGHR, and then when pause the video, complete those, and then check your answers. So please pause the video now. Here are my answers. So please pause the video here and check all of your answers and correct anything that needs to be corrected. So next style of question that we have is determine how many lines of symmetry each regular polygon has and draw them. So let's clarify regular. A regular polygon means all the angles are congruent, and it also means all the sides are congruent. Okay, so every single angle in the single polygon are equal and all the sides are equal. So first let's look at my triangle here. Let's see, we have a line of symmetry. If this is equal and equal and equal, then I should have a line of symmetry right down the middle. Now, if all three of those things are equal though, and you turn your paper, can you go ahead and turn your paper? I can't do that for you, but turn your paper and you have another line of symmetry right here, and then if you turn your paper again, you have another line of symmetry right here. So this one has 3 lines of symmetry. And each one of those, if I fold along that line, the 2 sides of the polygon will be equal on either side. So let's go ahead and draw the line of symmetry for a square. The first one I notice is the one right through the middle here and straight down the middle here. And then there are 2 more, actually, because this is equal and it's a square. One will be going through the diagonals. Each triangle on both sides will be equal. They'll both be 45, 45, 90 triangles. And then I can do it again to the other diagonal, leaving me with 4 lines of symmetry. So let's look at our last one. We have a pentagon, I believe. So first, I can draw straight down the middle. And again, if you rotate your paper, you should be able to go straight down the middle of each one. So from each corner, we should be able to draw a line of symmetry. I'm missing my corner over here. Like that. And once I have that, I don't think I have any other lines of symmetry. Let's count them. 1, 2, 3, 4, 5. This is not 6 because this is the same as 1. This one's the same as 2. This is the same as 3. This is the same as 4. This is the same as 5. So we're at 5 lines of symmetry. So let's look at this. Lines of symmetry blank the number of sides in the regular polygon. So if we look at our triangle, we had 3 sides, and we have 3 lines. If we look at our square, how many sides does that have? Well, it's got 4 sides and 4 lines of symmetry. And in my pentagon, there are also 5 sides and 5 lines of symmetry, which means the lines of symmetry will be equal to the number of sides, and again, only in a regular polygon. And we could do this one as well, but let's just write down how many lines of symmetry will this regular polygon have. Let's count our sides. 1, 2, 3, 4, 5, 6. So this will have 6 lines of symmetry. And again, you can always draw them in, corner to corner, and then write down the middles, and that should give you 6. Next page. So circle the following figures that have point or rotational symmetry. Okay, so rotational means if I turn it a little bit, it looks exactly as it did before I turned it. So when I look at the first one, this arrow, if I rotate that at all, it's going to look different. And when I rotate it 180 degrees, it's going to look like this. Don't laugh at my pictures. So that does not look exactly the same. So this one does not have point or rotational symmetry. Now when I look at the next figure, I'm going to go ahead and try and rotate that. I'm going to rotate it 90 degrees. And if I rotate it 90 degrees, I actually end up with the same figure. So this has rotational symmetry. Of 90 degrees. So I guess I'm supposed to circle the figure. There we go. The next one is regular, which means that is a square. And does that have rotational symmetry? And it does. Sorry, this one that we just did rotational symmetry, it's 90 degrees. It's also point. Because if something can be rotated 90 degrees and still have rotational symmetry, once you rotate it 180 degrees, it does as well. So for this one, we have, this one will also have rotational symmetry of 90 degrees, which means it also has point symmetry. Okay, so what I'd like you to do now is I would like for you to try the rest that are on this page. If you're not sure of the angle, that's fine. Don't worry about the degree so much as deciding whether the figure has point symmetry, rotational symmetry, or neither. So go ahead and work on the rest of these now, please. Here are my answers. I do just want to talk about the ones that have circles around them that have little tick marks. So what I was doing with the star, I knew it had rotational symmetry, but I wanted to figure out the degree. So I draw a circle all the way around, and because the star is regular, so to speak, then each of these little arcs, that one will be equal to the next one, will be equal to the squiggly one, will be equal to the next one, will be equal to the squiggly one, etc. So I did 360, because all the way around the circle is 360, and then I divided by 5 because there are 5 of these arcs. And that tells me that each one was 72. So that's how I was getting the degrees for my symmetries. So go ahead and make any corrections or changes to your paper and pause the video while you do that, please. So now we have this: draw a figure with one line of symmetry, draw a figure with no lines of symmetry, draw a figure with rotational symmetry, and draw a figure with both line and point symmetry. So I'd like for you to pause the video now and go ahead and fill in these figures, please. So pause the video now. Here are some possible answers. Of course, yours might not be here. If you have any questions about any of your answers, please write a note and be sure and have your teacher check what you drew. Moving on to the next one, so if you need to pause the video to write a note or check, please pause the video now. So we have a couple more questions about symmetry. What kind of symmetry does a glove have? So when you go outside and you put your gloves on, what kind of symmetry does that thing have? Now, the third question down says draw a picture of a glove. So I'm going to go ahead and draw my glove. That's my thumb. Let me go smaller, smaller. Okay, that's a terrible glove, but you know what I'm trying to say here. So here's my glove. The point is, does my glove have any kind of symmetry? And the answer to that is no. It does not have any kind of symmetry. The next one, is this the same as or different from the symmetry in a shirt? So I'm going to go ahead and do what it's asking me in the third line, which is to draw a shirt. And again, I'm just going to draw a basic t-shirt. So no laughing at your teacher's pictures. There we go. I guess technically there's something right there going on too. So here's my t-shirt, and my t-shirt should have a line of symmetry right down the middle. It should be exactly the same on both sides. So this is different than in a shirt. So what kind of symmetry does a shoe have? So if we look at a shoe, does a shoe have symmetry? And typically, no, our shoes do not actually have symmetry. If our two shoes were sitting next to each other, they would. Is this the same or different from a glove? And that's the same. Is this the same or different from the t-shirt? And that is different. So there's our little symmetry lesson. So moving on to our next topic, we are now talking about reflections. And a reflection is demonstrated right at the top of the page. A reflection is something that's been reflected over. So when you look in a pond and you can see those trees kind of reflected in the water, that's a reflection. When you look at yourself in the mirror, that's a reflection. So we're starting out with the dashed triangle. So we have this triangle that's dashed. That is a reflection of triangle LMN. So if I took LMN and reflected it about something, I would end up with the dashed triangle. So what line is it reflected across? Well, I don't know if you could tell me the line, but you could probably draw on the line. And the line, I'm going to squiggle it so you can see it. The line that we've reflected across is this line, otherwise known as the x-axis. And if I wanted to write that as an equation of the line, it would be written as y is equal to 0. Everywhere on the x-axis, the y value is 0. So I need to name the new triangle using prime notation. So let's take a moment to talk about prime notation. I know where L started. L was up here. And after a reflection, L should be the one furthest away from the x-axis, because L started out the furthest away from the x-axis above. The new L will be the furthest away from the x-axis below. So if my new L is down here, I'm going to call that L prime. So I put a little apostrophe after that, because that's my new L after reflection. So we're going to do the same thing with M. So M is over here. The new M is down here. and again, I put a prime after it. And then I have n. My new n is right here, and again, I put a prime after it. So the new triangle is called triangle L prime M prime N prime. Not very original. It's reflected, sorry, I guess I could have filled it all in here. It's reflected across the line y equals 0, or the x-axis, and the new triangle name is L prime M prime N prime. The letters need to match up. I knew what order to put them in because of the original triangle I was given up at the top was triangle LMN. Moving on to the next page. So we have these points. List the steps for reflecting triangle SDF over the x-axis and then over the y-axis. So what I'd like you to do right now, I would like for you to pause the video and plot those points. Okay, so pause the video now and plot S, D, and F. Here is S, D, F plotted. So the first thing that we're going to do together is we're going to reflect this over the x-axis. So I'm going to start with a point, and I'm going to write this down kind of as I go. So from S, count straight down, and I want to go straight down to the x-axis. Okay, so that's my first step. I'm going to move my screen a little bit. So from S, because I'm reflecting around the x-axis, I'm going to count down. So that is 1, 2, 3, 4, 5. So that is 5 units that I went down. So from there, count the same number again in the same direction. Okay, so from there where I just ended, I'm going to count the same direction in the same, the same number in the same direction. Again, I'm scrolling down a little bit. So I ended up kind of right here where that X is. I'm going to keep going down 5. 1, 2, 3, 4, 5. So this point is my new S, S prime. Now I'm going to do the same thing. Let's move on to D. The difference with S and D is S was above the x-axis, so I counted down to the x-axis. D is below the x-axis, so I'm going to count up to the x-axis. So from D, count up to x-axis, and then from there, count, same direction, the same number, same direction. And then for the last point, we're just going to repeat. So from D, I'm going to count to the x-axis, and that's just 1. And then from the x-axis, I'm going to count up 1 again. Here's my new D prime. Students get a little confused with that when the figure overlaps itself on reflection, but it's perfectly fine. So I'm going to do the same thing for F. So I start at F, and I count to the x-axis. 1, 2, 3, 4, 5. That was 5 units. So from the x-axis, I count up 5. 1, 2, 3, 4, 5. So this is where my new F is going to be. And then I need to be sure and draw my new triangle. And my new triangle connects F prime with D prime with S prime and then F. And it should look like a reflection. So in doing that, all I really was doing, if you wanted to look at the points, S prime, S was at 3, 5. S prime ends up, if you look at the points, 3, -5. So all that really changed was the sign of the y value. So let's look at D. D was at the point 1, -1. D prime, when I look at that, is at 1, +1. So again, the sign of the y value changed. When I look at F, F started at -4, -5. F prime is at -4, +5. So all I did was change the sign of the y value. Now, we end up doing the same idea with the y-axis. I'm just going to go ahead and tell you what happens. Instead of changing the sign of the y values, we end up changing the sign of the x values. I would have you do that right here, but right now your graph is a little bit cluttered. So I'm going to just write down just like we did before. So I have S was at 3, 5. My S prime would be at -3, 5. D was at 1, -1. D prime would be at -1, -1. And F was at -4, -5. F prime would be at 4, -5. And then you change the sign of the x values. Now, I prefer the counting method because I can never remember which one. So when I reflect over the x-axis, I change the sign of the y values, and when I reflect over the y-axis, I change the sign of the x values. If you can remember that, that's fantastic, and if you can't, then you can just do counting. Next page, what I would like for you to do, and this is one for you to do, I want you to do this reflection across the x-axis. So pause the video here, please, and do this reflection across the x-axis. Pause the video now. Here is my solution. I would pause the video here, make sure your points are in the right spots, make sure you wrote down the correct points. We're going to finish the remainder of the notes in class, so bring this packet with you to class with any questions that you have. So again, pause the video here, check your answers, correct anything you need to correct, and bring your questions to class. Have a wonderful evening.